Okay, we are solving equations for variables today. That is everybody's cue to stop talking. So it's going to be a really short, easy lesson today. I think. You guys will let me know. Okay, we don't really have key terms. You guys, whoops, can't see that. There we go. Yeah, so we're solving some equations for x. So solve for x and solve for x, and then we have to actually define what variables can't be equivalent to. So I'll explain what that means in just a second. So in terms of the other variables, indicate any restrictions on the values. Indicate any restrictions on the values of the variables. Okay, and I will explain exactly what that means in just a second. Okay, so x, let's start with this one. R times t times x equals c. R times t times x equals c. And basically all we're doing here is we're getting x by itself. So we're solving for x in terms of the other three variables in this equation, which are r, t, and c. So, does anybody have any suggestions about how we could do that? Lydia?
I have a question.
Yeah.
Is it like saying if r equals this and x equals this and c equals this, t, and like, you know, if this number is this, what is this number going to be?
Sort of. Sort of. We're actually just rearranging this to get x by itself.
Oh.
So think of it like this. If we had something like 3 times x equals 12, what would we do to both sides? Divide by 3. But instead of having 3 multiplied by x, we have r times t. Jazz? Right, good. Divide by r and t on both sides. Those cancel out. So x equals c divided by r t. Now, that's not the only thing. It says in our problem to indicate any restrictions on the values of the variables. How many people remember from Algebra 1 that you cannot divide a number by 0? You guys remember that? Okay, which means that dividing by 0, that's the same thing as the denominator of a fraction being 0. So the restrictions on this one would be that r cannot equal 0, because if r was 0, 0 times t would be 0, and then we would have a denominator of 0. And t also could not equal 0, because if t was 0, r times 0 is 0, and our denominator is 0. Okay, so that whole thing is our answer. Okay, questions on that? Okay, let's do another one. So how about x times a minus b? X times a minus b equals 2c. X times a minus b equals 2c. All right. You guys want to do the thing where you come up or no? No? Okay, we don't have to do that. All right, so this is again, x times a minus b. So we're doing the opposite of what's currently being done. Lydia? Good, perfect. Divide both sides by a minus b. Make sure you all can see that. You can. X equals 2c over a minus b. Okay. So you guys tell me, restriction-wise, what's going on here? Lydia? Good. I would agree with that. A cannot equal b. Now, can somebody explain a little bit more why that is the restriction? Marcy?
Because if a equaled b and b would minus b, then that means that they would cancel out and be 0.
Perfect. Exactly. Very well said. Okay, how are we doing on questions? You sure you guys don't want to come up? Is anyone still using this? Can I move it? We'll just move it up a little bit. There we go. All right. Okay, so what if we have something like this? Rx plus s equals t. Rx plus s equals t. Okay, Jared.
Want to subtract s?
Good, subtract s first, so start with the things that are farthest away from the x. So r times x equals t minus s. And then what would be a good next step here? Kendra. Perfect. Divide by r. So those cancel out. And x equals t minus s over r. Right, let me go ahead and move this up. Okay, restrictions on this? What do we think? If we can't have a denominator of 0, then that would mean a restriction of, what do you think? Stacy? R cannot equal 0. Perfect. All right, how are we doing on questions? Yeah, Lydia.
So this is like all we do?
This is all we do. We're just rearranging formulas. You guys are super speedy. Akashni.
So I learned this from my brother. You say like R can't equal 0.
Yes. Yes, you always want to indicate any restrictions on these. This is something actually when you guys get to pre-calculus, in terms of graphing equations, you'll find that this kind of thing is like a hole in the graph. It's really cool. So you'll get there next year. All right, so here we go. X, but I'm also kind of a math nerd, so I think things are really fun and cool that other people do not. So here we go. X over b plus c equals d minus f. So this does have a purpose as far as the restrictions thing. We just don't get to do that in as much depth as other classes do. Okay, here we go. So this is the last one of this type, and then we only have a couple more and we're done. Lessons always seem so short in this class. Okay. Chaz.
Okay, I'm not sure, but would you multiply both sides by b?
We can, yeah, let's actually wait to do that. Very good suggestion. So he said let's multiply both sides by b. That's exactly what we're going to do the next step. You can do it right now, but we don't necessarily need to. Akashni? Perfect. Subtract c first. So then we have x over b. Move it up a little bit. X over b equals d minus f minus c. And now we're going to do what Chaz suggested, which is multiply both sides by b to get rid of that denominator. So we get x equals, I'm going to take that b and move it up to the front, b times d minus f minus c. Now, remember the restrictions come into play whenever we have a denominator. So anybody have any ideas about the restrictions on this or whether they even exist? Elizabeth? Okay, that would be perfect if this was in a denominator. What do we think? Akashni? Okay, also a good suggestion if we had a denominator here. Stephanie? There are no restrictions. Why are there no restrictions on this one? There is no denominator, exactly. So that's what we would say, no restrictions. Okay, questions? Do we need a ton more examples? I mean, this is about the extent of what your homework looks like tonight. No? All right, let's do, ooh, I forgot about those. Okay, can I move this? Are you guys still using it? No, you're not using it. Okay, so here we go. So last set, and then we'll see how you feel after this. Solve each formula for the indicated variable. Solve each formula for the indicated variable. Okay. Let me see which one I want to do here. Okay, how about this? A equals P times 1 plus RT, and we're solving this for R. So A equals P times 1 plus RT, and we're solving it for R. So let me put a circle around that. That's the one that we're trying to get by itself. So there are a couple ways of doing this. Can anybody make a suggestion about one way to do it? A couple different ways, but what do we think? Lydia? Okay, that's one way. So she's saying distribute the P into the parentheses. So A equals P plus P times R times T. Okay. If that's the route we're taking, what would we do next? I think we can get away with this last example, and then we'll be good. Ashley?
Subtract P.
Okay, subtract P. So A minus P equals P times R times T. We're almost there. So now we have PRT equals all the stuff on the other side. If we're trying to get R by itself, what would be the next logical step here? Ashley?
Divide by PT.
Divide by PT, perfect. I forgot that there are two of you in this class. Sorry.
Did I just do that instead of her?
I did not make the
My bad.
distinction. That's my fault. Sorry. Okay, so A minus P over P times T. Okay, restrictions on this. Even though it doesn't say in the directions that we need to find restrictions, it's a good idea to get in the habit of doing that, because again, that's something you're going to have to do all the time when you get to pre-calculus. Marcy. Good. P cannot equal 0. Are there any others that cannot equal 0 or something else? Chaz? D cannot equal 0. Excellent. Now, did anybody solve this in a little bit of a different way? Because there is a different way, and the answer actually looks quite different. So, anybody do it differently? Marcy?
No, I wanted to ask you a question.
Yeah.
On the homework, if there are two restrictions, can we just, and they're the same thing, like, can we just put P and T cannot equal 0?
Yes, that's fine. That's fine. Other questions? Jared?
The other way to solve it, I would have divided by P.
Okay, good. So start by dividing by P first. So A over P equals 1 plus RT. Okay, if we were to carry this one through, what would we do next? Subtract 1. So let's move this up a teeny bit here. So A over P minus 1 equals R times T. And then the last step would be what? Divide by T. Okay. So R would equal A over P minus 1 all over T. That looks a little different, right? They both mean the same thing. But, same thing, different way of doing it. Now, if we wanted, so this is just a little bit extra here. If we wanted to get this so that it ends up looking the same as the other one, does anyone know how we would do that? Okay, Lydia?
Couldn't you just like move the P down and yeah.
Right, good. So we can separate this into two separate fractions, A over P times T minus 1 over T. Good. Let me move to another piece of paper here. How is it that we're able to do that, Lydia? Okay, it's okay. Marcy?
Did you make negative 1 into a fraction, so it'd be negative 1 over 1 and you multiply it? So
That's one way, yeah.
And then you multiply the denominator by 2 because it's the opposite of A divided by B.
Yes, if I'm understanding you correctly, yes. Good, very good. Okay, then if you notice again the last one that we got, it's all one fraction. So what would be the next step to getting this into all one fraction that, again, has a denominator of P times T? Stephanie? Good. So A over PT minus P over PT. And then now that we have the same denominator, we can combine them, A minus P over PT. Okay, so the point that I'm trying to get at here, and then same restrictions as before. The point, whoops, sorry about that. The point that I'm trying to get at is there are multiple ways of going about these, and sometimes, depending on how you solve it, you'll end up with something that looks way different but means the same thing, okay? This is not necessarily mathematically correct because you don't want to have fractions within fractions, so you do want to simplify it at least to this step, but, okay, questions? Okay, so your homework tonight, this is homework number 6, page 45, written exercises, not classroom, written exercises, numbers 4 through 60, multiples of 4. Okay, excuse me, one thing I'm going to bring back is if you finish your homework before the end of the period, you get extra credit. Okay, so I had a different extra credit thing in previous years, and I'm switching it back. Okay, so you guys have a lot of time left. You are super speed demons. So if you finish this before the end of the period, you get extra credit on this assignment. So that always helps. Okay?